Alrighty, good morning everybody and welcome to the wolfSSL live webinar about security in avionics with wolfSSL engineer Tesfa Mael. My name is Kajal Subkota and I will be moderating this webinar. All attendees will be in listen only mode. If you have any questions, please feel free to use the Q&A box to raise your hand or raise your hand to be unmuted if you would like to ask the question live, as we do host a Q&A session following the presentation. The webinar will also be recorded and made available on our YouTube channel shortly after the presentation. I invite you to also follow us on Twitter at wolfSSL, as well as any of our other socials. And please feel free to email us at facts@wolfssl.com if you have any additional questions. And now I'd like to give a brief company overview before we move on to the technical presentation. wolfSSL was founded in 2004 by Todd Auska and Larry Stefanik when they realized there wasn't an open source dual licensed embedded SSL library available. OpenSSL existed at the time, but there was a demand for an alternative that was easily portable, smaller, faster, available under a clear commercial license, was equipped with a clean and modern API, and offered commercial-style developer support. wolfSSL was born into this market need with an OpenSSL compatibility layer. Today, wolfSSL secures over 2 billion connections and over 1,000 OEM customers, as well as dozens of resellers. wolfSSL is made up of almost 40 dedicated employees in 2021, most of which are engineers. This process is, of course, supported by a strong partner network that we're very proud of, which includes ISRG, STMicro, and Curl, for example. Since the beginning, our engineering team has developed several embedded security products, including WolfCrypt with DO178 support, FIPS certification, and a FIPS-ready offering, MQTT up to the version 5 specification, SSH v2, TPM 2.0, a secure bootloader known as wolfboot, as well as Java wrappers and JSSE support, and commercial support for curl. All of these offerings are accompanied by a thorough maintenance and support plan up to the 24/7 level. We also offer full service consulting. And now I'm going to hand it over to Tesfa for the presentation.
Hey, thank you, Kajal. I am Tesfa Mael, and I've been with wolfSSL for over 2 years. Prior to wolfSSL, I worked at Wind River Systems doing the DO178C for a renowned VxWorks operating system. Prior to that, I worked at Lockheed Martin Space Systems Company doing modeling and simulation for avionics. So today we're going to talk about embedded security for avionics, why it's important, why it matters. So bear with me and let's see. So yeah, secure boot, secure update, and secure transport is what we will cover today. And you'll understand why it matters, what secure boot is all about, and I guess Kajal gave an overview of the product, but today we'll be covering the ones that are highlighted in yellow. The wolfCrypt, which is, you have 3 options. You can have a FIPS 140-2, and currently we're working on FIPS 140-3, which is the newest. And the emphasis of the presentation would be on DO178. We'll also talk about wolfboot, to do a firmware secure update, secure boot, and the rest are some Java wrappers, Python wrappers, and C# wrapper for our wolfSSL and wolfCrypt products. And we work with over 1,000 OEM, and we secure 2 billion connections. Our licensing model is dual license. So as an open source license, all our code is available for you to download, evaluate, and test. And if you need commercial license, you come to us, and all our code is um, homegrown. It's written by wolfSSL, and we are a clean room SSL and TLS and cryptography company. And we work with a broad partner, and some of them are captured here on the slide. And those aren't the only ones, but that's how much we can fit in one slide. All right, so what is DO-178 and why it matters? DO-178C is a software consideration in airborne systems and equipment certification. Um, it's pretty much a document that was put together and published by RTCA. And RTCA is made up of people from government, industry, academia, in the United States and around the world, representing all facets of the aviation community. And why does anyone care? Well, we at wolfSSL, we believe everyone deserves privacy, security, as well as safety by default. Because of commercial airplanes that fly over population or even increasingly military aircraft, as well as drones that fly over population, we want them to be safe. We don't want them to malfunction and cause any injuries. So that's why we certified our DO-178, our Wolf Group product to DO-178C. So when we talk about safety, I guess we need to cover what safety certification is and what is a certified system. So when we talk about safety, it's really a freedom from unacceptable risk. And when we talk about certification, we're talking about a demonstration of a confidence in the safety of a system. It's usually approved by an individual or a company that a set of software meets a safety standard set by the respective agency responsible for guaranteeing safety in a particular industry. In the United States, FAA, or the Federal Aviation Administration, uh, issues a certification for a system. But when we certify a system, the FAA certifies like the airplane, and as part of the airplane, you've got engines and propellers, and some components are certified as part of the bigger system, which is the airplane or engine. So software is part of the system component, and WolfCrypt, our cryptography algorithm, fit under the software, and every line of code must be clean and traceable to requirements and tests. So when you look at the RTCA document, um, there are a list of DO-178C objectives, and if you categorize them, there are 7 related to software planning process, another 7 for software development process, and so on and so forth. So for DO-178, there are 5 design assurance level, and our Wolf product is certifiable to level A. And for level A, there are 71 objectives. And for level B, there are 69 objectives. And for level C, there are 62, and D, 26, and so on. And to go from, as an example, from level B to level A, there are objectives that are related to MCDC, modified condition and decision condition coverage that your software needs to meet. And as an example, if you look at the RTCA document, one objective on table A5, it lists this the objectives and reference number, as well as if they're applicable to level A or level B or C or D. So for in this particular instance, this one uh, is needed for level A and level B software as part of the source code, which complies to low level requirement. You need to create artifacts or uh, data, and those need to be CM'd and be available as evidence. Um, and this is just an example of 7 out of the 71 objectives our software needs to meet. So our MVP product, which was released over a year ago, is WolfPrep DO170AC DAL-A features. It features a number of algorithms. And this cryptography is really a building block for secure boot, secure update, secure transport. We have certification data package available. And we completed stage of involvement SOI 1 to 4. So as far as the cryptography module, you get SHA-256 for message digest, RSA sign, and verify, with SHA-256 for public authentication. And you get AES GCM as well as AES CBC to encrypt and decrypt data. And also the AEAD or CHA-20 and Poly 1305. Poly 1305 is for Mac. CHA is a stream cipher. So when you combine the two, you get CHA-20 and Poly 1305, which gives you the same functionality as AES GCM. So by making this MVP product available, we enabled other products that are actually all products that are dependent on the cryptography, which is a building block for everything. So these are not the only algorithms that are available. We're actually currently working on making other ciphers available, like SHA-384 HMAC with SHA-256 or SHA-384, hash DRBG, AES in different mode, AES CMAC, as well as the ECC for sign, verify, and share secret, which is a complement for RSA sign and verify for public cryptography. So based on customer requirement, we continually to add certification evidence for cryptography algorithms. In terms of the code, when you look at the subset, what we've done is whatever that is available under our JPL license, we took that code and we slim it. I mean, if you look at, for example, AES, I mean, it's, I don't know, 10,000 lines of code, but we trim it to the bare C-level code. And we remove and redesign so we replace dynamic memory allocation with the stack allocation, so there isn't no malloc or free used. And the line count for our MVP product was 6,500. And the certification data package, when you view it, it contains 189 directories, 6,468 files, and there are 230 test procedures written, which are requirement-based tests that verifies the requirement for only 11 source code. So it's DO178 is really labor intensive, and it requires creating evidence and doing independent review and whatnot. So this will give you an idea of the kind of line of code count that we certified, and for other algorithms, something similar. For example, for ECC, you're looking at similar to RSA, about 1,000 something. And we've got math library that we're, depending on your architecture. In this case, this was certified for 32-bit architecture, but for 64-bit, it's a little bit more. So in terms of the process for creating the traceability artifacts, that one of the requirement for DO-178 is um, traceability from requirement all the way to test results, top, bottom, and bottom up. Um, and you need independence review for the requirement and design and whatnot. So someone who developed the requirement cannot review it. You need to get an independent body to verify that. Um, so we work with the certification house to perform to generate the certification evidence. So the certification house would perform code reviews and they file problem reports. wolfSSL owns the code, maintains the code, we fix the code, and more tests are uh, performed, like requirement coverage, structural coverage analysis, the modified condition and decision coverage. So for each decision, um, you need to look at every single condition and exercise that path to get coverage. Um, and requirement-based software testing, the 200 plus test procedures that verify the requirement of the software. And then at the end of it, so we create the certification data package, which is really a hyperlink media. You can put it in your computer and open it using a web browser. There's an index.html file that you open, and from the top, you can navigate all the way to the test results and back. And it makes it really easy to uh, understand the code, what it does, and that's what DO-178 traceability artifact is all about. Okay, so now that we've got the wolf crypt, which is the underpinning, which is a foundation for all our other product, we're going to talk about wolfSSL. TLS uses the cryptography. So usually TLS supported by major Linux distribution, wolfSSL that is, including Open WRT and Open Embedded Yocto. We've integrated wolfSSL with DDCI's DO-178C RTOS. We've got a TLS client and server example, as well as benchmark numbers. And Wolf Crypt, I think we covered this one already, but you've got 3 different options. You can actually, if you have a FIPS requirement, you can download the FIPS ready code, which does not contain the certification, and integrate it and test it. And when you're ready, you could come purchase a FIPS license for it. FIPS 140-2 is now set to expire sometime in June of this year. So we're currently working on getting FIPS 140-3 certification. So for DO-178C, based on customer demand and requirement. I mean, we covered the MVP product, and we also briefly covered the algorithms that we are currently working on creating a certification evidence for. And Wolf has been integrated and tested as an example with wolfboot, which is our secure boot solution. And by the way, wolfSSL does offer professional services for optimization and integration to your platform. So, for example, if you want to replace your U-boot with wolfboot, we can help you. Okay. Now that we covered the TLS transport, let's talk about secure or remote update. You know, when you talk about updates are really easy in most OSs, right? Because you could use a package manager for security updates. Well, um, most of them have advanced bootloaders that manages your partition and it can do kernel updates. Uh, but when you talk about microcontrollers or custom hardware, it's not really easy to do a remote update because there are no standards on remote updates. Each IoT vendor, they reinvent the wheel for firmware update, and uh, and most bare metal or RTO solution are still based on the old paradigm where they're using flat memory. So it's really easy to exploit um, unless safety and security constraints are added. Uh, and often, the um, rush to connectivity. I mean, there are so many available connectivity technology like Ethernet, Wi-Fi, or BLE, or in Avionics, you've got SpaceWire or 1553 and other proprietary interfaces. So that makes it really not easy to do a remote update. So everyone has homegrown solutions, but wolfSSL can really help you port to legacy target, so you don't have to invest a lot of time and money trying to get it right. So as far as the secure firmware update requirement, I mean, there isn't really a standard up until the firmware update architecture for Internet of Things draft, uh, which recommends that remote firmware transfer must be implemented in the application. So that way it's, um, it's not dependent on the connectivity technology. And that requirement is still in a draft, but it's the basis for uh, our wolf boot. So the bootloader must provide secure mechanism based on asymmetric cryptography to verify the authenticity and the integrity of the firmware. So based on the draft, we came up with the summary of the requirement here. Um, so you can pull up the draft and read the requirement if you're interested. Uh, and that's how Wolfboot Secure Boot was born. So initially, the Secure Boot loader for the 32-bit microcontroller. Um, so the design was simple. So it was OS agnostic. It runs on a 32-bit microcontroller in ARM Cortex-M, RISC-V, and MIPS32 support under development. So is the x86. Uh, so firmware verified at boot time using ECC, ECDSA provided by WolfCrypt. Um, so there isn't any additional hardware required. We do have support for platform-specific trusted element and hardware encryption mechanism. If your target supported to accelerate cryptography, we are able to leverage that. And it can be chained with a boot stage to integrate with other bootloaders. Um, and it supports multi-slot partitioning of the programming flash. Uh, it supports for update from external SPI Flash if you don't have enough memory on your target. So that's a really neat feature. Now we'll go through a use case at a high level a bit. So for the update management, there are two possible strategies implemented by Wolfboot. The first one is AB approach, and the second one is boot and update. The AB approach is provided for position-independent firmware image, and it's not recommended for microcontroller with physical memory mapping constraint because it introduced execution in place constraint to be known at a compile time, and it does not allow using external NV uh, memories to store the updates. So what we recommend is the boot and update approach. So basically, you've got the active firmware always boot from the same partition, and updates are stored in a second partition, and the content of the two partition is a swap during installation, and a second swap operation is performed in case of a fallback. So when you look at the system architecture, it looks like you've got wolf boot, which depends on wolf prep. Wolf prep, you can get it in 3 different flavor, including the DR178C. Um, and then you've got the public key trust anchor, as well as if your target supports the secure element, then you may have some drivers that need to access it. And your wolf boot, um, there is a small hardware abstraction layer, which interfaces with the flash. It wants to be you want to be able to access a flash, open, read, write, erase. Um, so you've got, in terms of firmware, you've got an application or RTOS at the top, and your application wolfSSL sits at the application layer. So your application can interface with wolfSSL. This is for doing secure transport TLS. And wolfSSL also depends on wolfprep, which you could get in 3 different flavors again. And wolfSSL can, for TLS connection, you would need to use a TCP/IP stack, but you don't really. I mean, the TLS, our TLS library is transport agnostic. You can use it, over serial or other interfaces, just using a callback. But the most common one is TCP/IP, so that's why we have here the TCP/IP stack accesses your network driver, and then you've got your board support package and drivers, as well as a flash driver, which Wolfboot needs to access, and your application can talk to a Wolfboot as well. Um, so they're, Wolfboot and TLS are independent. So if you look at the secure boot software components, so the application talks to a Wolf boot, and there are only 2 APIs. The application requests, they do an update, and Wolf boot will go perform that. And then application can say confirm update has been done. And the Wolf boot contains the public key, and it talks to, again, wolf prep, 3 different flavor. And for wolf boot, the hardware abstraction layer, that is required for each target. I mean, it's very minimum. We've got a set of examples for different architectures. You can have a look on GitHub, but the hardware abstraction layer that's needed to unlock the flash, write to the flash, erase a flash, or lock the flash. So those are the target-specific hardware abstraction. It may need to talk to target-specific hardware abstraction or BSP driver, or direct registry access if your target comes with them. And in addition, there are some assembly optimization in our cryptography. So if you, depending on what kind of performance requirement you have and what kind of footprint requirement that you have, you may choose to use the assembly optimization. In most cases, it gives you bigger footprint, but then faster. And those options are available in those can be configured for wolfboot. Here, the wolfcrypt engine, crypto engine, it can, if your target support secure element, you can leverage that to speed cryptography. Again, if you've got assembly, if you need assembly optimization, I think we've got it for most common platform, um, for ARM, for x86, uh, RISC, and I think PPC is lacking, but we've got assembly optimization to speed up the cryptography operation. So secure update mechanism. So for the multi-slot partitioning approach that we covered, so you need a small, about 32 kilobyte partition for the bootloader at the beginning of the flash. And then you need the boot partition, which contains the current executing firmware. And the update partition is the same size as the boot partition, which will contain the update. And there's another one, which is a swap partition, which is a small, which is used internally by wolfboot to provide fallback. So in case something goes wrong in the middle, states the status and state of the update is stored in the swap partition. So in terms of generating key and signing, the first step is you generate the private key and public key. And then the public key, wolfboot takes a public key. And then you've got the private key, your firmware and version number. And then you take the private key, you sign your firmware. Right? The version number is important because you want to prevent fallback attack. So so that's added. And once you sign the firmware, you want to send it to your target, which is sitting somewhere remotely. So if you want to ensure your firmware is received through a secure channel, then you could use our TLS or DTLS for this channel here. So once you receive it on your target, your application will issue update, and the public key is already part of wolfboot, and it authenticates the firmware. If everything succeeds, then you can update your firmware and your new image will be used. If not, then the old firmware image will continue to be used. So the final application will be stored at the boot partition. And the only thing is the start address of the application code, whether you're using bare metal or OS, it must be set by the linker to 256 byte after the beginning of the partition. Usually, it's just sufficient to edit the flash section of your linker script. And in this particular case, you change the length to here to 600. So if you look at the package header, it contains a whole bunch of stuff like the magic sequence number, the firmware size, the type, the tag version, the timestamp, the length, the timestamp, what kind of hashing algorithms that are used, SHA-256, or I think other SHA-512 is also supported, and the length, and then the digest for your firmware, and the signature. And for the signature, you've got a few available options, whether it is add 2519 or ECC with different curves, or RSA, INTAG. So you've got your wolf boot, you've got your header, and then you've got your firmware. If you were to look at the layout. Okay, let's go over a real life use case. So usually you've got a target in the lab and you can access it via JTAG. So what you do is you create 3 partitions. You get the bootloader space, the boot partition, and update partition in a small swap space. So using your JTAG, you burn your wolf boot on the first partition here, and then your target is deployed sitting somewhere. Um, um, well, sorry. First, you need to burn the firmware, the factory firmware, before you remove the JTAG and deploy your target. So you take the firmware, version number, and private key. You sign and you install the factory firmware on the first partition, right? Once this is done, when the system boots, it's gonna always boot from the factory firmware. So you will remove JTAG and your target is deployed happily in the field somewhere. Now, let's say you want to do a secure remote firmware update. So what you need to do is do the same thing. You take the private key, it never leaves, you don't share it, never leaves your server. The firmware image and the version number, you up it, you sign it, and you transmit the firmware through TLS to your target. So on your target, the application is responsible to receive the firmware update, and then it issues update to a wolfboot. So wolfboot, under normal operating condition, wolfboot verifies the integrity and the authenticity of the current firmware every time the device boots up. So the update would go here on this second partition. Yeah, I don't count this partition, so I'm starting with the current firmware, which is a partition number 1, and then partition number 2 here. So wolfboot is notified about the update and does the following, right? So it checks a new image is newer than the existing one to prevent rollback attack. It verifies the integrity of the firmware image using SHA-256, and it verifies the authenticity via the digital signature of the firmware digest. So if the update verification is successful, the update is started by swapping the content of the 2 partition. So you had the firmware update here, and then you do a swap, and the status or the state is kept in the swap space. So at next boot up, if the update is confirmed by setting a flag on the flash, the old firmware is erased, and the system can boot normally. And now the update partition is empty. From this moment, the system is ready to receive the next update. So this one is the success case. So the firmware has been verified and booted. So if the update does not boot properly, then you need to restore the previous firmware by initiating a swap operation. So during the next boot up, the system can boot normally again. So in this case, update was not done. The previous firmware image was booted. So the other feature that I briefly mentioned is the use for SPI Flash. So if you don't have enough room in your flash, this is a really nice feature because your update would go to your firmware update in the SPI Flash, and your current firmware would occupy your whatever flash you have. In terms of the hardware abstraction layer, to be able to read, write, erase operation in the external SPI Flash, those functions need to be implemented. Examples are available for a few architecture. So very minimum code. As far as digital signature algorithm, there are 3 DSA mechanisms supported currently. The ED 25519, the ECC SEC P256R1 curve, RSA 2048, as well as 4096. Need to update the slide. Um, and assembly optimization in ECC secure elements available on some platform may speed up your boot up procedure even further. And if you've got a TPM that is supported to speed up the verification step and reduce the bootloader size, so Wolfboot can directly talk to TPM, which is a really neat feature. Okay, just to recap, so wolfSSL brings TLS security to Avionics. You could do a secure transport, secure update. And we covered DO-178 and some safety acronyms. I mean, DO-178 is not no, right? Was the first version was published in 1982, but the DO-178 sees the latest and greatest, which is published in 2011. And you need to do secure updates because they're important, whether you're fixing defects on the field or for critical vulnerability management. So you can leverage Wolfboot to save time and effort. And Wolfboot has been integrated and tested with the DO-178 Wolfcrypt. And you can leverage secure firmware authentication, as well as a reliable update mechanism. So for any other thing, wolfSSL offers support for customization, performance optimization, fine-tuning in your environment. And you can always contact us at support@wolfSSL.com for more details or if you've got specific questions. And with that,
thank you so much for attending the Security and Avionics webinar. As a reminder, this webinar is recorded and will be made available on our YouTube channel shortly following the presentation. If you would also like to get a copy of the presentation, please email us your request and we'd love to send you a PDF of the PowerPoint. And I also invite everyone to follow us on Twitter at wolfSSL, as well as all of our other socials. And always, if you have any questions, please feel free to email us at facts@wolfSSL.com or at support@wolfSSL.com, and we'd love to help you. Thank you so much.